Hello, hello, hello. Welcome. Thank you so much for joining us today. My name is Nitya Narasimhan. I'm a person with shoulder-length black hair wearing a patterned dress, and I'm coming to you straight from New York. I'm a senior cloud advocate on the AI advocacy team, and I'm joined by my colleague, Professor Lee Stott. Hi, Lee.
Hi, Nitya. Hi, everyone. I'm Lee Stott. I'm a Principal Cloud Advocate Lead at Microsoft in our AI team. Work very closely with Nitya, who's co-presenting with me today. We're really excited to be here. So I'm from the UK. I'm currently wearing a grey hoodie, and I'm a white individual who's over the age of 40. So I'm getting quite old, hence grey hair.
I left my gray hair out of the picture, but we should go on to the next slide. Today, we are going to teach you how to train a model and debug it with the Responsible AI dashboard. And this particular module is part of a bigger challenge. And I really want you to go ahead and make sure you have those links down. It's part of the Microsoft AI Learn AI Skills Challenge. It has a number of modules that will take you from the basics all the way to advanced concepts to build end-to-end AI applications. So today, we're going to be looking at one of those in the AI Learn Cloud Skills Challenge. And Lee, there's a bunch of Learn Live series coming after this, if I'm not mistaken.
There is, yeah. So this is part 6 of our separate set of series. So you can see we started this back on March the 20th, and we're progressing through this from beginner up to advanced level. So we're partway through that course. So, you know, we're at that intermediate level now where we're going to get into some detail. We're using a lot more Azure services. And today's session is all focused around training and debugging a model with what we call the Responsible AI dashboard. So this is all about how you use AI responsibly. And then next week, we'll go into more in-depth series, which we'll talk about at the end of this session. So today is all about responsible AI. To help us today, we have Cynthia. So Cynthia is one of our cloud advocates as well within the team. So Cynthia is our online moderator. So if you do have questions or comments, please do post them in the chat. We're going to be looking at the chat as well. This is live, so we do love interaction and participation. So please do ask some questions in the chat. Cynthia will highlight some of the top ones. We'll also be looking at that as well. So first of all, welcome to everyone around the globe. So Cynthia is currently in Brazil. So again, we have a global team here. We've got US, UK, Brazil. So we've got lots of people on this call to help you.
And if you want to follow along, go check that link out. You can snap the QR code or go to aka.ms/learnlive-2024-0410A. Easy to remember, that's the date. And that will take you to the page that you see on the right. Now, this is a Learn module. So it has both units, lesson units that will teach you the core concepts. And we're really excited because this has a live lab session where we will walk you through the process step by step of how you will actually do this in practice with Azure. So before we go into that, let's go to the next slide, just a quick second. As Lee mentioned, half of the value for you is to ask questions. So feel free to go on and post your questions in the chat. If we don't get to any of them, we will be sure to answer them later on as well. So there's no bad question, just post them in there. And I think we should move to the next slide so we get a sense of what we're going to learn. So if Lee and I do our jobs right, by the end of this session, you should know what responsible AI means, what the core principles of responsible AI are, and how you will apply them in practice as you build and train your own machine learning models. You will learn how to create a responsible AI dashboard on Azure. Once you've got that dashboard on Azure connected to your model, you will be able to learn how to use specific tools to do the following things. You will be able to understand where the error, or like do an error analysis and understand where the error rates on your model may be unevenly distributed. You will figure out how to use those tools to look for biases, to figure out if your data is under or overrepresented for the various demographics, so you are able to do fairness in the way you kind of assess these decisions. Next, we're going to look at explainability or interpretability. You not only want to build a model, you want to understand how that model impacts the outcomes that come out of it. And last but not least, we'll talk briefly about how you can use this information to mitigate your own your models for responsible AI practices to meet compliance or governance needs. Next. So how are we structuring this today? Today, we're going to, if you look at the Learn module, we're going to talk through some of the lesson units interactively. And then when we jump into the exercise, you'll find the exercise is actually laid out in this format, and we'll go into details later. We'll launch a lab. We'll show you what the responsible AI dashboard is, go through using those different tools, complete the lab, do a knowledge check, And then we'll wrap it all up by reinforcing what you learned. Next. All right, I think I'm doing this one right. Okay. So what are we going to do today? I hope you're all familiar a little bit with Python and Jupyter Notebooks. The whole lab exercise is structured as 2 notebooks for convenience. The first one is basics of just setting up, training your model, and deploying it to Azure. The second one is where we'll dive into how you would construct a responsible AI dashboard associated with your model, and then walk through all the exercises that show you how to debug it for responsible AI practices. The thing I want you to kind of look at really briefly is that we are using the UCI hospital diabetes dataset as the basis. Totally encourage you, once you've looked at this, to go pick up your own dataset and try it out with your own ideas. But in this particular case, this dataset represents 10 years of information, medical records, from 130 US hospitals that look at patients diagnosed with diabetes. It has 50 plus features based on a number of different attributes like age, gender, race, how many prior inpatient visits they had, etc. And it provides a bunch of outcomes, including one that we will look at, which kind of tries to predict, will this patient be readmitted or not? Next.
Yeah, I'm just going to add to that, Nitty. I think it's really important that, you know, all this is going to be hosted within a sandbox environment, number one. So no one needs any subscriptions, no access. So before you start to panic of, oh, how do I do this? You don't need to worry about it. It's all going to be here.
That's right. And you get a free Azure subscription to work in the sandbox. It's great. So I'm going to hand over to Lee so we can kind of get the introduction to responsible AI.
Yeah, so let's just talk a little bit about, you know, AI and where we are today. AI is a tremendously fast-moving ecosystem. You know, if we look at where AI has come from in the last 2 years, things like ChatGPT weren't available. And it's really being used across all different industries. You know, people are looking at it from an industrial perspective around creating innovation. Organizations want to adopt it because it's, you know, it's hugely cost saving. It's going to add massive value to the organization. And it's also really changing the way us as users, you know, as the citizens interact with technology, whether it's things like ChatGPT, which is now available, to machine learning models, to self-driving cars. AI is everywhere, and responsible AI is now becoming the key facet to utilization of data responsibly. So not just the data itself, but how it's implemented. And this really leads to lots of regulations and government impositions on data, because we want it to be fair, we want it to be transparent, we want it to be equitable. So AI regulations are going to be the key foundations to how organizations and individuals utilize this data, because this data is trained on our data, it's trained on us, it's trained on how we interact with systems and how we behave with systems. So it's really key that we think about AI from a responsible perspective from the get-go of an application development. You know, what do we want to do with the data? How are we going to utilize that data? And just because we can do it, should we be doing it? I think that's a key message we want to try and get across around this, is just because the technology is there, should you actually be doing this? So if you look at building responsible AI systems, we really have these key pillars. So as I said, you know, fairness, reliability and safety, privacy and security, inclusiveness. So this is looking at those 4 principles of your data that you are collecting. And then we look at the outcomes of that data. So the transparency of that data. Can you, as an organization or as an individual, prove where that data was coming from? Was that data captured in the correct way? Was it stored in the correct way? Is it being made accessible in a correct way or a transparent way where you feel like there is trust within that data that you're providing? And then, of course, accountability is so key, because accountability of that data is, you know, as you're an individual or as a developer or as an organization, is key. You know, you want to be accountable to the data that you hold, how that data is being utilized, and how the systems that you're building are utilized. So it's really about how we build those trustworthy and ethical systems that capture data in a responsible way, that analyze the data in a responsible way, and then allow you to consume the data in a responsible way. So there are core principles to how we want to structure responsible AI services. And we have massive involvement across Microsoft in terms of how we run data responsibility. We have a group called AETHA, which is really our ethics panel, where if internal to Microsoft, if we want to build with AI technologies, we have to prove all these different facets to then be able to implement that service model or implementation. So when I talk about responsible AI, it's really not just the developer who's responsible for building the solution. There's these three key scenario stakeholders. So we've got the AI model developer, so the programmer or the person who's developing the software and the systems. We've got the business decision maker or the business leader who typically, is driving the strategy of the organization to why they should be utilizing AI. But they also need to be, have clarity and understanding of those key principles. So going back to what I just said about accountability, trustworthiness, are they gathering data in the correct way? Are they storing the data in the correct way? Are they doing that data storage, collection, aggregation to government standards? Because, they're ultimately going to be responsible if the company is fined or impeached for doing things wrong. And then we have the user. So the user could be internal to the organization, internal to the business, or it could be an actual consumer who is utilizing that service to carry out an application, a service, or even paying for that service to be utilized. So there are three key scenario people within any AI implementation or any solution. So Nitya, over to you to talk about what is the responsible AI dashboard.
Yeah, and by the way, I'm going to also give a shout out to Carlotta, who's on the call, on the chat, who's also from our team. So say hi to her. She's also one of the experts you can reach out to if you've got questions. So I want to segue from what Lee said. Absolutely. We need to talk about what the responsible AI dashboard is. But to get there first, let me talk about the toolbox. So you heard about those 6 principles, right? But we are developers. We are people who might be building end-to-end solutions. How do we translate those principles into practice? So first, I want to talk to you about the responsible AI toolbox, and the link is on that slide. The responsible AI toolbox comes from Microsoft Research, and it's actually started off as a collection of open source tools. Hugely encourage you to go check that out. But the basis behind it is that in the open source environment, there are a lot of reputable organizations, research organizations like Microsoft and others, who are building tools that can help us determine if some of these principles are being complied with. As an example, there's an error analysis tool that can help you look at the error rates in your model, not just at the high level and say, what's the average error rate, but that can help you dive in and say, is this error rate being distributed evenly? Are there certain demographics that are getting a higher error rate or being impacted adversely? And how do we fix that? Fairness assessment. There are tools out there that look at the data and say, wait, if there are characteristics like gender or age or ethnicity, are we distributing the data in a way that everyone is equally represented? Are we unfairly overrepresenting a part of the population? Model interpretability. There are tools that will help you figure out or explain why the model made a decision that it made. Data analysis. We're all familiar with EDA, which is really basic Python data analysis or other tools. So you want to understand the characteristics of your data. How is it distributed? Are they categorical data, numerical data, and more? Counterfactual analysis, we'll also talk about on the other side in decision making. But it's really saying, okay, we've built this model and we've shipped it, but we really want to understand 2 things. It gave an outcome to the user. Can I actually say what if? What if I were to try something different? Would the outcome change, and can I explain that? And the other side is, okay, the user got an outcome. What could they have done differently to get a desired outcome? So if I'm building a loan application, for instance, and it makes a decision that this user is not eligible for a loan, can I figure out, hey, maybe these are 2 or 3 things you could do to make sure that your record is now going to get a desirable outcome later? So those kinds of things are what we're looking at in that space. So if you look at the left side of this toolbox, we're really looking at tools that help you debug your model. So you're going to start on the left by first identifying what are the areas where my model has issues. Error analysis and fairness assessment. Is my data representative? Have I got or are there cohorts that have more errors? Diagnose. Once I know these errors, or once I know that I have a kind of issues in the model, how do I dive in with tools that help me kind of zoom in on what the errors are and where they are? And then I want to look at tools that will help me mitigate them. Now, we're not going to cover that in the dashboard today. The green elements are part of also what's called the responsible AI dashboard. Now, this is the responsible AI toolbox, which is a collection of tools. You can use it in open source. But if you are a person who's building these models for production, you want to operationalize them. The Responsible AI dashboard is in the Azure Machine Learning Studio. And what it does is it takes this from like the domain of you trying stuff out to being able to integrate it into a pipeline. So when you deploy your model, you can hook it up to the dashboard and see all of this stuff through a unified pane of glass. Now, I keep saying the single pane of glass. Why is that important? Because if you didn't have something like this dashboard, what happens is you become the data mule. You have to go to every one of these tools and look at what the implications are for your data. What the Azure Responsible AI dashboard does is it creates a unified dashboard that plugs all these tools in, lets you go seamlessly from one to the other against the data and model that you've provided. The easy integration on Azure is really what we want to focus on in this module. So I'm going to go to the next slide. By the way, the components that are in there, the ones that you saw, we'll kind of see if we can talk about it later, but this is a better way for you to look at it. So if you look at the Responsible AI dashboard, there are actually two buckets in which the tools fall. On the left, you see model debugging. On the right, you see business decision making. Model debugging is when you as a data scientist or a developer, because really everything is shifting left. Developers are becoming data scientists in their own right. As you start building your model, those are the components or the components of the dashboard that help you answer questions like, can I detect errors? Can I diagnose? Can I remediate, right? And you'll see that list of tools. Error analysis, we talked about. Data exploration, how do I know the characteristics of my data? Model overview, you're looking at performance of the model. Fairness assessment, interpretability. Business decision-making, saying, okay, I've made a decision. Now I want to know how the prediction of the model impacts real users. What is that decision doing? Causal analysis is saying, are there features in this that have a higher impact on that decision? How do I know? I can perturb the model and see what is the causal effect of a change in a feature on that prediction. Counterfactual is saying, what if I change this? How does that change the decision? So we're not going to cover the right side. Totally encourage you to go add those to the dashboard on your own and explore them. But today you're going to learn how to do the left side. Set up your model, hook in the dashboard, add all of those components, and figure out how you're going to analyze your data based on them. Next slide.
Yeah, so just to jump in, Nitya. So Stephen's asked a great question around, guardrails and keeping data secure and secret. So just to stress that, Stephen, this is about responsible AI. So when we're looking at this, your data is already in Azure. So, your organization data is secure because it's in Azure, it's in your Azure subscription. And what we're doing is we're actually analyzing that data to do exactly what is on the left-hand side of this slide. So it's, can we detect errors in the data? So we're looking at this from a responsibility perspective. So when we say errors, is there bias in the data? Can we diagnose the cause of that bias? Because, is the data set being captured from the wrong sources, or are we over-indexing in certain territories, for example? And then it's about, once we understand those issues, what are the steps that we can take within our model, within the machine learning model, to remediate those issues? So, what can we do to change the model output? So can we train it with more data? Can we reduce some of the data? Can we reduce those biases in the data to produce a better model? So we're not going to really talk about security of your data because that's within Azure security. So I just wanted to stress that point.
No, it's an excellent point. And I will also reinforce that if you looked at the original principles, safety and reliability and security data privacy were kind of like two big pillars. So this toolbox may not address all of them, but there are other kind of tools in the Azure toolbox that will help you make sure that you can do governance, you can kind of lock in the security to access to the data and so on. But before we kind of switch gears and start going through some of the actual notebooks, let's quickly recap what we'll do. When you want to use the Responsible AI dashboard for model debugging, as you saw in the previous picture, the workflow is you identify your errors, you find out where in your data you're getting the most error rates and issues around fairness. Then you diagnose it, use the tools to drill down and find out what are the causes of it. And then based on that, you will get insights that you can use to mitigate the model. So what kind of errors? Where are those prevalent? What causes them? Where should I focus my resources so I'm actually maximizing the responsible AI compliance? And finally, the mitigation. So we'll do this in 3 stages. If we go to the next slide, we're going to talk about how we're going to do that in the... Oh, but we should actually have a discussion on this. That's right. Sorry. I'll let you lead this one.
Yes. So just covering really some of the points that Nitya raised before, if you talk about using the Responsible AI Toolkit, which is an open source set of Python libraries, basically, it creates a lot of issues for people who are not traditional data scientists, because, you know, you've got no centralized locations of your data. Your data could be anywhere, in any format, in any type. So you might be using things from Excel to databases to raw text files with a Python script. So, you know, what that actually involved was data scientists spending lots of time trying to figure out, how do I get all this data? How do I put it all together? And how do I develop a model around this data? That really resulted in them using lots of different tools. They had to communicate with different teams. Did they have permissions to those Excel files? Were those Excel files actually in a data storage, or were they on someone's individual machine and they were given a USB stick? So it creates a lot of complexity when you look at how you go from building an open source model to then trying to build those metrics and visualizations that allow you to actually compare. And also, once you have those data points and visualizations, how do you present those to business decision makers for them to make informed decisions on which way they want to go with their product or service? So these are all the challenges that, you know, really Responsible AI dashboards, that single pane, and as Nitty said, is there to really cure, to support, because this is just simply a portal within Azure, which is a web page. That's what it comes down to. It's simply like a web page which displays all your results in a single view, and you can explode those out. You can copy them out and put them into PowerPoint decks, etc. So it's centralized all that resource.
Yeah, and I think the key thing there is the visualization. The whole notion of the dashboard being a tool that you can drill down with just drop down, so you don't code anymore. You can you have like a no code experience to analyze your data. And I want to reinforce that again, like with the tools, as Lee mentioned, all of these are Python libraries. You can code them yourself and mix and match them and try to figure it out. With Azure, you basically can focus your time on what matters, which is understanding the data. There was someone who asked a question, Lee. I don't know if you saw that. And he made a comment, I guess, says, you can overcome so many rules by asking a question differently. And I think that's actually interesting. But I also want to make sure that I think like we're looking at MLOps and LLMOps and large language models and things like that. So there are, when we're looking at this particular application, it's a data model you create, right? You can lock down a lot of the things that you're allowing people to do with it. And it's really about the prediction endpoints that you're building. But I will move us to the next slide unless you had something to add, Lee. Okay.
No. I think that's a fair statement. I think, you know, again, it's about understanding, and this is why this data set is so good, because I think everybody understands diabetes. Everybody knows it's a disease. Everybody understands what the root causes are and how it can impact people. So again, it's about understanding the data from a business context of what you want to achieve with that data. Because I think that's another big problem, is where people don't understand what they want to achieve or what they expect to achieve, and then try to retrofit models to fit those assumptions which may not be valid.
It's true. So we're going to start our process of kind of diving into the meat of this module right now. And the first part is Notebook 1. So if you've been following on your Launch That lab, we'll kind of briefly talk about what you're going to do in this first part of the exercise. So in Lab 1, which is going to focus on Notebook 1, we are going to build a machine learning model based on the UCI diabetes dataset. As I mentioned before, that diabetes dataset has a whole number of attributes. And what we're going to do for this is we're going to use a platform and an environment called Scalable. If you who are joining Launch Lab yourself, you should see something like this. So briefly, to kind of get you familiar with the environment that you'll use, when you launch this, you are actually getting a VM in a browser that has a Windows VM on the left and an instruction manual on the right. This particular environment comes with its own Azure subscription. And as you'll see on this, when you start off, it'll give you a password that you would use to log into this session. And you will then have 2 hours to complete the lab on your own. When you log into this session, you get a pre-configured Windows 11 VM. So you don't have to do anything to install anything at all. That VM has a default Visual Studio code editor that we're going to show you. In that editor are installed extensions that will let you launch and use Jupyter Notebooks as a runtime with the Python environment underneath. And there is a default subscription provided for every login. So you will have access to an Azure sandbox, and you can actually use this to deploy the model and check out the Azure Responsible AI dashboard right in the browser. So next slide. When once you've set this up, the very first notebook, which is the focus of our current next segment, is where you're going to build and register your model. So the first thing you'll do before you get started in launching the notebook is you will find, and it's in the instructions on Scalable, once you log in, launch your VS Code editor, go into the terminal, and you will find an AZ login command that's given to you. So one of the things I want to point out is in Scalable, and Lee will show that to you when we look at it interactively later, you don't have to even type anything. You can actually literally click stuff on the right instructions, and it'll type that in for you wherever the prompt is. So in this case, you'll find an instruction for AZ login. That will help you log in with the Azure subscription, with your Azure credential given in that particular session. And when that's done, you will have a configuration.json file that will help you work with that subscription in your local environment. At that point, you will start using this first notebook. And in this first notebook, we will walk through the steps that will help you build and train your machine learning model on the diabetes dataset using scikit-learn. Once that's done, one of the tasks, the next task there is we'll create a cloud client and actually push this to Azure and have it train on Azure. You will learn how to set up a compute cluster, how to run a training job, and have your model registered in Azure ready to go. At that point, you are now ready to debug it. So if you kind of look at the thing, well, let's do this live. Are we ready? I wasn't sure.
All right, yeah. We are ready,
yeah.
So let's do this live. So I'm going to switch over to my demo machine now. So I'm currently in the Scalable lab. So as you can all see, we have the lab environment here. So this is the lab instructions. So you can see the lab instructions are on the right-hand side. And again, it clearly says, you know, if you see this green T, it is a copy and paste feature. So this allows you to copy and paste directly into your IDE or into a browser, anything that is shown within the instructions. So I've already been starting this lab while Nitty was speaking, because it takes about 10 minutes to run this. So I just want to quickly highlight to you some of the key areas of what we have. So as I said, this is a sandbox virtual machine. So this is provisioned with access to Azure. So you have a password and a username for the Windows machine. You also have a username and a password for your Microsoft Azure subscription, which is very nice. And what we do in the first steps is literally go through by, first of all, we use the AZ login command to log into Azure, and we use those credentials to log into Azure. And this provisions us a subscription access. So you can see it's done the AZ login command, and it's provisioned access to an existing Azure subscription there. What we then do is we actually look at this command and we run the next command, which is this AZ ML workspace create. So what this is doing, it's actually creating a Azure Machine Learning workspace in our Azure subscription, and it's provisioning that to the East US data center. So what we're doing just by simply running this single command is building that environment. We're then going to configure this workspace by in Visual Studio Code by adding a config.json file. So this is the config.json file, which you can see here is just simply exactly the same. So I can just minimize this down here, this terminal. So this is just literally copied in. This is a config to allow us to have our notebook speak to our Azure subscription, basically. That's all that config.json does. It allows you to execute the notebook on this virtual machine. So this could be your personal machine, but the config.json is where it's going to create that connection to your Azure subscription. What we're going to do is we're going to open up Lab Notebook 1, which is our training notebook. And what this training notebook is literally, it's a Python notebook. So this is what we call a Jupyter notebook. And each of these cells can either be marked down or code. In this example, we've got a code cell with a comment. The first code cell is simply, we're going to be using the pandas data library to import the data set. So this is our data set. This is the data which is all around our model of our diabetes model. So we're loading that data set to our service. We're then going to be using scikit-learn to train the data. So what's really good about these instructions is if once you step through the instructions in the instruction guide, it will explain to you what each of these different sections of code do. So as you can see here, we've got our scikit-learn model. And again, we don't want to spend too much time on going through each of these different cells. But this is provisioning our model and building our model ready for deployment to the cloud. So this is the whole idea of what we want to do. We want to train a model, deploy it to our Azure subscription so that we can utilize it within the actual module itself, within the next unit itself. So we're registering the training data set. So we're going to call it the hospital training data set. We're using that data file that we provided earlier on. So that's a data set that we provided. And again, this is in your local model. So there's a data set. So, this is very, very straightforward things. We're also going to create a compute cluster because we want some compute in the cloud to allow us to actually run and execute this job. So in this section, what we're doing is we're creating a compute cluster called compute training 1. And it's going to be a standard data science 12 V2 machine with 4 cores. So again, this is quite a cost-effective machine. It's not an expensive machine to run. And then we're going to create the job, which is going to run and register the environments for us. So this takes around 10 minutes to register this model and deploy the model to the cloud, which is very simplistic. So when we... sorry.
I was going to say, could we just show them where they set the kernel? When they start off, they probably would have...
Oh, yes. Good point. Good point. So when we actually start to execute the notebook, there will be a select kernel option here at the top. So you can see in this screen, it says open the top and select kernel. So we select the kernel and we select build 2023. And then we simply run all, and that will run all the notebook. As I said, the instructions are really excellent within the Microsoft Learn modules as they guide you through and provide instructions to what each code segment just does. So as I said, they'll break down each task. So as you can see, task 2 is here, and it literally says what we need to do in task 3. So we've got task 3, register your data set. It explains the Python code. It says what this is going to do. And then you can see the data is being registered in the machine learning module, etc. So this is what's really great about the Learn environment is it's literally all built into the same experience.
Yeah, I was one of the things, I don't know if you can show task 5 for just a second. So the 2 value propositions of doing this module is when you finish it, you can walk away without worrying about the Azure resources. They'll get torn down. But if you run this in your own Azure subscription, make sure that you can shut them down. But I want to focus on this one because if you want to understand what the question is that we're asking, this tells you what the prediction is. And you can see that what we're actually focusing on among all the different attributes available in the data set is the readmit status. In other words, we're trying to train a model that uses that particular outcome to predict whether a patient would be readmitted or not. So that's kind of like the focus for this. I'm just bringing this up because I think there are some scikit-learn modules that also do predictions for other things.
Yeah, so just to stress, what we're trying to do is look at the readmission. So will someone go back into hospital after a set number of days of not being in hospital? Yeah, so it's readmission back into hospital. Again, this is explained as well very clearly in the instructions. Again, this takes about 10 minutes to execute. So you can see I've already just pre-executed this. You can see how long it's taken for each section to execute. So like last section's 1 minute 7, but building the model and deploying the model is 7 minutes 31.
And I think that once this is run, we can actually switch into the Azure ML Studio and see some of the kind of like the workspace. You can see the jobs, the result of the job, and the registered model.
Exactly. So when we come down to the steps, it says if we click on the machine learning model, we can actually see. So when we go into our machine learning model, this is what our data set looks like. So we have our model environment. So this is the model that has been deployed. So it's called Hospital Admissions Model 1. So if we go back to our code, you can see that's the actual model that was deployed. We can then go into our responsible AI toolkit as well and see that the model is actually there ready to be viewed. But that's something we'll cover in the next sessions, in the next example.
Yeah, and I'm just seeing some of the messages. So I think some of you are getting the lab error. So this lab is a little rate limited because we've had so many people use it. If you have an issue, wait a couple of days or wait a couple of hours, sorry, and try it again. If you continue to have the error, please do leave a message for us. We're going to try to get that fixed, but you should be able to see it. And the other person said, how do I launch Visual Studio Code Terminal? That one, Lee could actually just, if you flip over to the Visual Studio Code, tab. Yeah, I think there's a way for us to either, you can go
Yeah,
to the
very
menu.
good point. So if you just go to view and then go to terminal. So under the view command at the top, then terminal, and then terminal will pop up. You might need to just expand the terminal window. So you can see my terminal window is very small at the bottom, but you can just go down and you can drag that up. So you can then make it larger. And you can see like, oh, then you can actually start to, you know, have a bit more real estate for entering commands, etc. So make sure you do select terminal here as well. Sometimes you do end up with like debug console, but there is a terminal option. If your screen resolution is very small, you may have 3 dots just at the end here. If you click the 3 dots, the additional menus that are not visible will show. So that should help those who are having issues see my terminal list. So view, then terminal, then drag this up if you can't see the terminal option. So this is the only slider that will be at the bottom of the screen. So it's very simple to identify, and then make sure terminal is visible. Does that help?
I think so. And I really love that the community is all helping each other. People are actually posting solutions. So
awesome.
this is awesome. And by the way, if you have any issues opening the lab, this is recorded. So we hope you will come back, open that up later when it's fixed, and follow the instructions here. So
another key, I was just going to stress another key thing is outline, which is a great little feature of the Explorer bar within Visual Studio. Is when you open up the solution, it's asked you to actually open up the folder. Sorry. So first of all, it asks you to open up the folder so you get the whole hierarchy of the workspace. So you do open folder, choose the build the Azure ML folder, which is on the local machine because this is a virtual machine. And then you get the entire folder structure. So you can see the folder structure. Now, outline is really good because what outline does is when you open up a notebook, it takes each of the topic headings from the notebook. So like you can see these tasks and creates an outline. So straight away, you have a visible way of seeing what the tasks that are involved in this notebook. And then you can work through each of these tasks. So task 1, task 2, task 3. So before you saw me struggling with scrolling up and down, which is really difficult on a virtual machine sometimes with latency, by opening outline, it makes it much more simpler to interact with where you are in the notebook. So that's a top tip for especially when you're using virtual machines or what we call Visual Studio code spaces, where you might have quite a bit of latency on your internet connections.
It's one of my favorite features. And I'll also encourage you, if you have any issues or have questions, just literally cite which part of that outline you're in. You can be like, hey, I'm in task 2 and I had a question. And that's an easy way for us to connect things to you.
Definitely.
Someone had a question. Do you want to take interactive questions? I think it's probably good, right, Lee?
Yeah.
So someone's asking, Nithya, you mentioned fairness, error, and fairness mitigation in your slide to make the model responsible. Question is fairness from whose point of view in many times when it's B2C data? So in here, when we think about fairness, if you go back to, when Lee was talking about the different pillars of responsible AI, one of those pillars is fairness. And when we talk about fairness, the simplest way to think about it is your model treating everybody the same? And when you say everybody, can be fairness based on gender, age, ability, race, ethnicity. There's so many different criteria. Or if you look at a particular domain, there might be other things that are criteria for fairness, right? So when you say whose point of view, what we're doing is we're training a model based on data to answer a question. Let's put it in the use case that matters, diabetes. Here we are predicting whether you're going to get readmitted to the hospital in 30 days. Now, if you think abstractly, it's a model. If you think in the real world, that decision is what the doctor is going to give a patient, which makes the difference between them being readmitted or not. And so fairness says, are we making the right decision for everyone, independent of criteria that defines a particular subgroup? So we'll see some of this when you go through the data. When I make a decision to say, you will get readmitted, but you won't, and it turns out that you should not have gotten readmitted, but you did, and now you're paying the hospital bill for something you didn't need, or someone else was told you don't need to get readmitted, but they were actually in critical condition. These are all issues. So when we dive into them, We want to ask, was this something that our model generally made a mistake on across everyone? Or was it doing this specifically in a different way for this demographic, right? And we'll see that. And that's really kind of tying it back to the data. So when you're saying fairness, it's the point of view. And if you remember Lee putting the slide up, there are different stakeholders. It's a point of view of everyone involved. The model developer, are you being fair in the way you've gathered data? The decision maker, are you being fair in how you use the prediction for different demographics? The application user, are you getting a fair shake? Are you being told why in a way that you understand, right? I hope that explains it. And sorry, Lee, if you want to add something else.
No, I was just going to add as well, is one of the nice features around the exercises within the sandbox is when you're actually working through it, there's this lovely feature of a chat box. So again, when you're actually working through, you can say, look, I wanted to go into Visual Studio Code. Yep. I want to close a terminal. I want to then open the notebook. And you can, and what that really does, it gives you a visual cue to where you are within these modules as well. So straight away, you can jump back and go, okay, I'm up to section 5 now. So I need to go and select the Python environment. So I go up to Python, select the Python environment. Next one. Okay. So what I want to do now is select. Yep. So I did that one as well. Great. Now I want to do run all. So I click run all. And it just gives you that visual progress as you're working through the module. Because honestly, when you're working with notebooks, the general biggest mistake people make is not executing a certain function or a cell in the right order, or trying to rerun things when you've already run them. Honestly, that's like the biggest issue people will have. So just working through this in a sequential manner and utilizing this resource really, really does help immensely in terms of mitigating those issues.
Okay, so this part is a simple one. So we should go to the next exercise, which is actually the most interesting one for you to understand how all these tools work. So
definitely.
Yeah, so hopefully, I think, are we switching to slides for a second?
Yes, so let's just switch back to the slides for a second.
Okay, thank you. So in the next section, we're going to look at the second notebook. Lee already showed you how you can load a notebook into Visual Studio Code. So you're going to look for the second notebook. And that notebook, I believe, is called it'll be
Notebook 2.
Notebook. And what you're going to do in there is two things. First, you are going to create a responsible AI dashboard. And in this case, we will actually step through the code a little bit to explain what's happening. You're going to create a responsible AI dashboard. Now, in the version that we will create, we've only added a couple of components. As you will see, if you go look at the documentation or you read the responsible AI toolbox, there are actually a number of tools. Challenge yourself when you're done to add another tool and see what happens. So when you use the create responsible AI dashboard step, you will first start by setting up an authenticated ML client. You've already seen how that was. You've got the config.json. Your Visual Studio Code already knows how to talk to your machine learning workspace. Now you will construct that responsible AI dashboard by identifying the different components. We'll look through the code and then creating that insights dashboard with a pipeline that's basically saying, hey, take the inputs of the outputs of all of these tools and feed them into this insights dashboard, which will actually visualize it for you. Once you've done that, you can then go into Azure Machine Learning Studio, click on your model, find the responsible AI tab, open it up, and there you go. You will see all the visualized widgets that will allow you to kind of look through your data. Can you go to the next slide, please? So this part of it, this snapshot is showing you what that pipeline looks like. So if you remember, we're going to construct, and all of this we're going to do in code in the notebook. You construct it, you submit a pipeline job. This particular one is actually showing you the pipeline that has your two tools that building the insights dashboard. If you look at the documentation, you'll see how you can add other tools as well. The thing about this is familiarize yourself with the Azure Machine Learning Studio UI. That is your biggest friend. Because when you go into the Azure ML Studio UI, that's like a low-code experience. The more you click around and explore it, you've got nothing to lose. The more you'll understand all the different capabilities. You can monitor progress. So for example, for some reason, if your job fails, you will see an error here. You can click on that box to figure out what happened. Did I not put the right data? Was there something wrong? Did I run out of compute? Whatever it is, you will be able to debug it. You can visualize progression. So as Lee mentioned, this job takes a while to complete. So when you're watching the Studio UI, you can actually see which parts of the pipeline are complete. And that kind of gives you a very interactive sense of how much more you've got to go. Once you've got this done, you can then select on the left side, you'll see there's models, data, jobs, etc. Go to models, pick the model that you just registered. You will find that it has a Responsible AI dashboard tab. Click that, you'll open it up, and that's where your Responsible AI dashboard, once the pipeline is complete, that's where you'll be able to start working with it interactively. And I think, given like time, maybe we could just dive straight in. Yeah, thanks, Lee.
Yeah,
I wasn't sure if you'd run the notebook already.
So let's go through. So yeah, task 2. So we're going to open up the second notebook. So notebook number 2.
Yep.
Again, I've already pre-run this because we are tight on time. This does take a few minutes. So again, we're in exercise 2. So we're on the next exercise. It says open up the notebook 2. Yep. Select the kernel. Yep. And then start to progress through this. So select the Python environment, which I've done. And then click run all. So you click run all, which starts to run. Again, I have the outline view.
Yep.
So the first section is the authentication of the ML model. So this again is going to go off and utilize the authentication method to connect to that model. So this is using the actual name of the registry. So it's Azure ML. It's going to use the credentials that we provided, so that username and password, and then authenticate to this model. Again, as we said previously, each of these steps is defined in here. So it does explain what this model does throughout each of the different steps. Again, task 2 is going to define and create the dashboard. So if we look at these different categories, is there a specific one you want to look at, Nitya?
I'm going to look over here, and let's go to the one which says define dashboard components.
Yeah.
Yeah, so this is this helps you understand how the kind of dashboard is orchestrated. So you'll see that, first of all, it's getting a constructor for this, right? So you're looking at what your RAI dashboard constructor is. You've got the 2 components there. We're looking at 2 things now: an explanation, so that's your interpretability component, and then there's an error analysis component. So you're getting those 2 components listed down there. And then if you scroll down further, let me see if I can, yeah. So now what you're doing here is you're basically saying those are the 2 components, and then I'm going to have a gather component. The gather component is really saying all the tools you've defined, I'm going to have a pipeline that pipes their outputs into this. This will gather everything and create the insights for you. That's the one that visualizes everything for you in one place. So if you scroll down a little bit further, I think it actually will show you the constructor. Okay, we don't need to know all the details, but if you're curious, definitely read through this. This is the place where we're setting the job. We're creating the job that actually creates that insights dashboard. And you'll notice it sets the 2 things up. The one thing that's interesting here is you see that pipeline. Now, if you go down a little bit further, you've created that component, and then you'll see how it actually changes the output of your tool into this, right? So you can kind of, yeah, so you're initializing that, gathering that insights component first, then you're giving it the 2 different tools, and now in your pipeline, you will see these different components. Those are created, they're connected in. I think that's mainly what I wanted them to look at. If you go all the way to the bottom, now we're adding the explanation. So there you can see that once you've created that original insights gathering thing, now here you're hooking that up, the insights dashboard create job. It's taking the output and from the explain job and moving it into insights. The next one is doing the same thing for error analysis. At the end of this, you've got yourself a dashboard component that has all the different tools unified in one interface. Now, when you run this, you've basically got like this job when it's complete. If we switch over to the Azure Machine Learning Studio, you submit the pipeline, you should be able to see the pipeline there. I think it should have completed by now.
Just to confirm some of these things, so this was actually one of the questions that was in the chat. So it was like, you know, how does the model get deployed? So basically what we're doing is using the notebook itself. So this is Python to define the name. So we're calling the dashboard RAA dashboard. So we're not using the JSON file, we're using the notebook Python to build the model. So when we go back into our Azure portal, here's our notebook. You know, here's the notebook has now built the model and called it RAA dashboard. So straight away, we can then start to look at what these resources are.
And someone asked a question, Jason said, and this is a perfect time for you to ask a question, said, does it show any kind of leveled hierarchy among the dashboard components or lateral interrelations? So if you remember the dashboard components, right, each component does something specific, but it all starts with error analysis. And when we walk through the different components, so the answer is yes and no. The
Yes.
answer is yes, because the very first step you will do is error analysis, where you basically, before you even start, if you remember that pipeline, like the diagram said, identify, diagnose, mitigate. So the first step when you want to identify things, you're doing this by creating cohorts, right? So once you get that, then there is a hierarchy. You can pass that cohort to every tool and say, can you dive into it based on this, based on this? And each tool, because it understands its capabilities, is going to give you visual things that you can tune. You can say, okay, drop down and give me this particular set of criteria. Let me change the range of which I want to like look at data for, etc. And we'll see that in a second. I hope that answers your question. But what I want to kind of have you think about is that some of these tools will have interrelationships. For example, the error analysis cohort is used by others. Others may not need to have one. They can operate directly on the data. But the unified dashboard hides that all from you. You don't need to care. You just know that you have to give it your data sets, your model, and off you go. Sorry, Ernie.
And again, that's great. And again, a lot of this code is like templatized code. So, it's just basically a change of names, change of data sets, because the scikit-learn model is exactly the same. So think about this as a great way of getting started with responsible AI with a known data set, then try and build this again with your new data, with your own data set, and just change those parameters within the notebook to create names related to your new data set as such.
Yep. We should start going through the exercises.
Yep.
Yeah, let's start looking through the debugging. So exercise 3. I think we had a slide on it, but let's skip it and just stay in here because we get more fun. But basically, so what we're going to do now is we're going to dive into this and start doing the exercises that look at the 4 tools. So Lee already told you how once you've got your model deployed, you can click the model, go in and find your dashboard, launch the dashboard, and you see this single pane of glass. It's a single web page inside Azure that shows you everything. So now let's follow the instructions as we go. The very first thing you're going to do is error analysis.
Error analysis, exactly, yeah.
Yeah, so go ahead, Lee.
So basically what we have here is we have the error analysis of our data set. So this is basically like a historical view of all our different data. So it gives us the number of different data. So let me just change this zoom so you can see it a little bit clearer.
So I'll just set context for this really quickly, if that's okay, Lee.
Yep.
So the thing that you want to use this for, which is super important, is that when we talk about data models, like we usually say, okay, here is the accuracy, right? We'll say it's like 80% accurate. What does that mean? It means that the model as a whole can be 80% accurate. But if I start looking by demographic, if I start looking by different combinations, it may turn out that for a particular demographic, most of the time the model is not right. How do we know that? So in this particular case, that root node, this is a hierarchical root view. That root node is giving you 2 numbers, 112 and 696, I think. So what it's saying is we have a data set that had 696 records. And of those 112, the prediction was not right. So for the rest, it was. So like when you look at that split for each one, inside each node, you're going to see 2 numbers. It's going to say how many people were in that node. On the right is how many records were kind of being analyzed to get that node. Left side is telling you how many were wrong or how many had error. So when you look at the root of the tree, it's for the entire data set. But then as you start walking down the tree, it's really kind of saying, based on this feature, now I'm looking at the subset of the data that matches that feature. Now let's see what the error rates look like. And the big thing is that the darker the orange color, the worse your error rate is. The lighter the color, the better it is. In other words, light grays are really good. The model's doing very well. Dark oranges are very bad. The model's not being representative. And so that becomes the important thing for us. Sorry, Lee, go ahead.
No, exactly. So as you were just talking then, I was literally just explaining this in terms of the visuals. So as Nitty said, when you click on a node within each of these areas, it gives you the statistics. It gives you a statistics as a flyover. Again, this might not be visible because it's quite small, but you do get this data instance here on the side. So it's saying there's 696 records in our data set. From the initial model, 584 are correct, 112 are wrong. So this is the statement you get about false positives, so especially like within or false negatives, depending on especially in medical situations, you want your accuracy to be as high as possible to mitigate that issue of problems. So as Nitty said, if you look at the different, each node is a different color. So the nodes that are the gray colors are really, a good accuracy, and the less grey colour, the better the accuracy. So, you know, that's our best route. The darker colours are where we have the worst errors. So this is the worst node within our example. And you can see, you know, in this instance, it's got 39 total, sorry. 23 were correct and 16 were incorrect. So this is where we see the biggest variance of issues around that data set. So, you know, this is where we need to start thinking, what does this issue relate to? Why is it causing this problem? And again, in terms of the guidance, it literally starts to explain this to you, that, you know, if you look at these leaves, you can see where the data is. And what we can do is we can start to compare good versus bad to then see what the impact of this is. So if we take an example of the best route, which is this one here at the bottom, which is like all correct, no incorrect items. So that's perfect. That means the model on this side is ideal. So what we'd like to do is basically compare the bad versus the good.
Yeah, so we've got to save two cohorts. I don't know if they were already saved.
Exactly. I've already saved the cohorts. Don't worry. I'm prepared. So what we're going to do is we're going to compare these cohorts. So this is the next section where it just asks us to select the cohorts that we've done and then compare these cohorts. So it asks us to save them with different names. And then we're going to actually look at the analysis of these two different cohorts. So if we look at the feature cohorts.
So the cohorts right now are really kind of saving based on the features that went down that tree. So you've got two cohorts, yeah. And then when you're comparing them here, it's saying based on those features, how are they comparable? So do you want to look at the... Okay.
Sorry, there you
go. So this is a good way for you to like look at how you're comparing those two, right? You're seeing on the one hand, and I think the two cohorts in here were based on, you made a new cohort based on age.
Yes.
Okay. So you can look at this and say the cohorts here are being chosen based on age, but if you'd kind of gone through the exercise, you might have had a different set of features. You really want to look at this, and for each one of these, you're looking at the sample size. Then you're looking at what the accuracy scores are, false positive, false negative. And here, the accuracy is for the whole model. But as Lee mentioned, false positive says, hey, this person was falsely told that they had to be readmitted. In other words, they were told they had to be readmitted, but they didn't need to be. False negative means they should have been admitted, but they were told they didn't have to be. And what you're seeing in here is you've got to look at two different things. One is when you look at the accuracy, higher accuracy is always good. And I can't see totally the colors on this, so Lee, please help me out.
Yeah,
let me know.
Zoom in, sorry.
Yeah, and I don't know if we have the cohorts that were in the notebook, but
yeah, let me go back to the model overview and go.
Yeah, if we use those, then I think we can also reflect on the kind of insights that they were talking about. Yeah, so over here, right, like when you look at this and what you're looking at is how many people are in that cohort, like what is the sample size that was used to define the cohort. And then when you look at the false positive, false negative rates, you can figure out what is the impact of that. So for example, if you've got a data set based on this where there were just 4 people in the cohort, right? Then it really you don't have enough data. That might be something you want to think about. Do I have enough data to make this decision? If you're looking at something where the false positive, like if the accuracy is good, but the false positive rates are high, is this the one that was for the default? So I'm kind of looking at the model overview picture for...
Let me check.
Okay.
Should be.
I think if you pick the 2 nodes and save them as cohorts, and it just compares those two. So was this one saved as a cohort? This one was called false. We can actually look at the image that's in the notebook if you like, Lee, because I think that's...
Yeah.
Yeah. So if you pick those two nodes, you pick the one with the highest error rate and the one with the lowest error rate, save them as cohorts and then add them in, you will get something exactly like this. And what you want to look at in here is the all data cohort is like looking at everyone, all the data, right? So it's all your sample size is the entire data set. And it says accuracy is pretty good, no problems there. Now look at the one with the lowest error rate. That was the gray cohort, right? It had low error rate. And when you look at this, the accuracy score is 1. It's like, hey, everyone in here is doing well. We were really 100% correct when we came to making predictions here. But you will notice that the erroneous cohort, the one that had a high error rate, that's the second one, that has a score of 59%. That means like 59%. That means 41% of people were not necessarily getting the right prediction. And the thing that you want to dive into here is like, okay, how do I mitigate this? But I look at the number of records I have. It means that, like, I think this is 30, right? The sample size of 39, right? Yeah, the sample size is 39, right? So the model's not performing well for those people, but that can also maybe give us an insight for mitigation on, hey, how do I increase this? Like I can, first of all, drill into this particular cohort, figure out what the issues were, but then maybe I need to bring in more data. So false positive rates, you can look at the false positive rates for all cohorts now and say, okay, how did my model perform in terms of false positives, where it basically told people they had to be readmitted, but they didn't have to be. And you'll see that for all of them, it was decent. In other words, this was actually performing very well for telling people not to be readmitted. False negative is when it says you don't need to be readmitted, but you have to be, right? And this is more critical because maybe you have to go to the hospital, but your doctor says, according to this, you don't need to. So over here, what we're looking at is that the false negative rates, I can't see the thing in here. So the false negative rate is close to 1, right?
Yeah,
so
0.837, yeah.
Yeah, so there's a high number of cases where it's not predicting the patient will be, or it's incorrectly predicting that the patient shouldn't be readmitted, but they should have been. So here, this is kind of where we want to drill into it because we want to say, okay, what are the issues here? So how do we do this? This is when Lee was showing you the feature cohort analysis. If you switch into the feature cohort analysis, you can now kind of look at it in terms of the features. So the original one, we just looked at the cohort as a whole. So if you scroll down, we can look at the images in the notebook if that's easier. But if you created this and went to the next level, the original analysis we did was by the cohort as a whole. When you switch to the feature mode, you can look at the breakdown. You can say, is it based on this prior inpatient? For this particular diabetes example, the prior inpatient feature happens to have a lot of impact, right? Were they a prior inpatient or not? So if you kind of go on the right side through the notebook. Yeah, we can just walk through this one, might be easier.
It's easy to see.
Because you'll see this when you actually run yours. But this way lets us kind of walk through this. So we went through the first part, which is the kind of like the error analysis. We were in there. And under error analysis, we went through the savior cohort, do this for the feature cohorts. So now right there. Yeah. So in the feature cohort, you're basically looking at it and saying, what are based on that inpatient. If you go up a little bit more, Lee. Yep. So we see here that the prior inpatient, that was the big feature, right? So when that was less than 3.67, the sample size, the top low says everyone, that means pretty much everyone in our data set had less than 4 prior visits. That's good. And for that, the majority of patients were hospitalized less than 4 times in the past. The accuracy is good. That's your general kind of like baseline, right? Now look at the ones for which the second thing is where we have the highest error rate. The third is where we have the lowest error rate. For the highest error rate, first of all, when we look at that demographic, there are only 17 patients in this data set. So our accuracy is low because you're getting 64% as the accuracy. But are we confident that this model is doing the wrong thing when I only got 17 data records to base this on? So that's something that we would need to explore further, right? And then the other one where you're looking at is the false negative is 0. That means that in this particular case, it's correctly predicting when they should be readmitted, right? So the thing that you want to take away is, yes, there's something to be looked at in here, but what do I do for the data? Now, if you scroll down further, the last one is when people are kind of saying, for the case where the prior inpatient has more than 7 visits, our prediction accuracy is actually 0.75. there are no inaccuracies. But look at the size. We're basing this on just 4 people. So are we kind of like giving the right prediction? Should we be expanding that? So what this is really showing you is once you've looked at the cohorts, you can drill down on the different features that led you to that cohort and then try to analyze whether one feature was more critical than the other. If you go down further to the next one for data analysis, do we want to do that one next?
Yeah. I was just going to stress as well, when you see, just for people who've never done this before, if you see 0.844, that is 84.4%. Okay, so don't think of this as being less than 1. So 1 is 100%. So just to stress that to people who've never done this before.
Yes. So what you saw in that particular thing was looking at model performance. Now we're looking at the data, because now we're beginning to see, okay, wait a minute. We need to really understand, am I getting the right data set that I'm running my model on? In the data analysis, if you kind of walk through the instructions, you will get to this point. Yeah.
So go on, I'm just going to show it here and then.
Okay. So in this case, what data analysis lets you do is you can go in and you can see how all the different data, all the data in yours based on the different kinds of buckets that you're using for the left side. Like you can see how are the data records kind of grouped into different buckets here. So here, I think you're looking at race on the left side right now. So it's saying based on race, we've got and the colors are telling you African-American. Do you have the key?
Yeah,
okay,
yeah. So it's African-American, Caucasian, and Hispanic.
Yeah. So when you look at this, you're saying, okay, based on the records, I'm seeing how race is a factor in distributing the records across all of this, right? So we've got and over here you can see, and the next one will actually tell you if you can set this based on race. You'll very clearly see that this particular data set is highly biased towards Caucasians and is underrepresented in terms of all the other races. So I think...
I don't know if you can see the numbers as I'm just doing a mouse hover over. But yeah, Caucasian is in every single group, whereas Hispanic is pretty much not available. Again, you can also change this to be other data set predictors. So again, we can look at the age, we can look at gender, and that allows us to then identify is the biases within the data set.
And when you look at this, you can kind of start understanding that you are either overrepresenting a population that is for a particular feature, or you're underrepresenting them and you want to balance that data set. But the second thing that you can do, and this is just like, if you flip, this is one of the nice things about the dashboard, is you can get different views into the same data by kind of flipping what elements or attributes you're zooming in on. So in this case, it's kind of looking at the true values and the count, just in were you readmitted or not readmitted. So you can go over the whole data, and it's asking, was it representative in getting data from populations that were readmitted versus not? And you can see over here, kind of explains why our model often seems to be really good at telling you when you shouldn't be readmitted, because we've got a lot more records that we can use to analyze and come up with the right prediction. We don't have enough on the other side. So now we're beginning to see gaps in our data. Now I think the next one was talking about race distribution. So we kind of had already covered that. If you keep going, like that was the example for the race. So, and then the next one talks about gender. As Lee was saying, if you flip to, instead of using race as your attribute, if you flip to using gender, we're okay. We're kind of evenly distributed. So that is not an issue for a fairness or for a kind of like equitable distribution of data, because we're getting almost equal male and female patients.
Exactly, yeah.
Yep. And if you look at age,
we have an index.
Yes. And if you look at age, and that's one of the interesting insights that the data gives you, if you look at age as the attribute, you will find that it does look like it's not evenly distributed, right? The 30 years or younger is a really small sliver, very few patients. We have very little data on that demographic. We have a lot of data on the demographic for over 60 and kind of in the middle for 30 to 60. And you can ask yourself, is this a representation issue, or is it kind of valid because of the domain? And this is where having a domain expert who has knowledge of the space is useful, because they can say, you know what, this is not about representation. This is actually right. As you get older, you're more likely to come into hospital. The more people are going to have diabetes as they're older. So we're not like unfairly representing them. It might be kind of relevant to that particular question that you're asking. And over here, though, we can ask, is the 30 and younger so underrepresented? Is that correct? And what we're really asking is it possible that like they're not just showing up in the hospital, but we really kind of don't know them? Should we be looking for more data? Because maybe, I'll just say this, we might have a kind of like a diabetes issue among the younger children, right? So how do we make sure that's corrected? So what you understand from the data analysis part is you can now look at your data. You can basically analyze it and say, how representative is it for the different features? But now, once you've got there, you really want to know, yeah, now I'm getting the sense of the shape of my data, right? I can use this dashboard, use that tool, get the shape of my data. But what's important? Like, am I going to try to make sure everything is evenly represented? Should I? And this kind of goes to two things. One is responsible AI principles, fairness, but also the cost. Like, do I want to get data for everything? Am I overfitting, underfitting, right? So over here, when we look at this, the next set, which is really looking at feature importance, is saying, once I know underrepresentation and overrepresentation, then I'm looking at where I'm making decisions right now, which features in this data set have the highest impact on those decisions. And so I think, are we seeing the right thing on the right? Which one are we looking at, Lee?
Yep, so one's the real one, one's the dashboard, one's the instruction. So I just wanted to show that, you know, you can manipulate the view and change the data however you wish. So again, you know, once you start to understand this, these are all definable dashboards which you can interact with and change the filters. And again, so you know, this is all definable by you, and it's just like using Excel. You know, none of this is programming, as you can see. This is just like using a WYSIWYG. What do I want in the feature? So at the moment, I've got 4. On this example, it's got 17. So if I wanted to go up to 17, I can change the number of features, and it will give me more features. But I might only be interested in the first 4, so I'm just going to zoom in into those.
And this is actually super important, and it'll emphasize this in the notebook too. Let's say, can you just zoom out to maybe like 10 for a second, Lee?
Yep.
So usually the top 5 features, what it's doing is it's giving you the default view, saying in terms of importance, right? So if you look at the top features, those are the ones you want to focus on to say, okay, if anything perturbs them, it's going to have an impact on the decision. But you also want to expand the window to see where attributes like race land up. So in this case, if race had ended up being one of the top 5 features, then you know that race is being treated as a feature that will actually impact the decision. And that means that your model is not necessarily fair. You got to look into it a little bit more. But right now, race is maybe in the 6th or 7th. There might still be issues in specific cohorts, but you want to start looking at, you know, the distribution. So to what Lee's point was, if you expand out and see all the attributes, you should also use your own insight as a subject matter expert in the domain to kind of understand what the implications of those features are when you analyze them. Sorry, Lee, go ahead.
No, that was a great overview. So again, you know, it's fully explained in the instructions. So you can go through and it explains what each of the models are for.
Yeah.
This is like so important in terms of those different features. That's the key thing around this, is being able to identify errors that you've already identified. So for example, we knew there was an issue with race. So it allows us to delve deeper into where the data is. So like, as soon as I've clicked on this, it's like, oh my God, as Nitya said, oops, there is a massive issue that our data set is just all Caucasians. We've got no Asian, we've got no other, we've got one, what is it? One Hispanic and a few segments of African Americans. So straight away, it's identified to us that immediate issue. So again, you know, you can start to delve into this data to see what are the different impacts we're having based on the data set we have. So have we got bias within that data set?
And the thing that kind of, when we were looking at the original, like all the features, we were looking at the aggregate feature dashboard. But I think in the same thing, you'll find a tab that will look at the individual feature importance. So if we look at that, to the point we're making here, I think if you, if you go down further, keep going. Yeah, right there. You see there's an aggregate feature importance and an individual feature importance. So the aggregate one lets you look at features at a macro level across all the records in your data set, right? You're like saying, okay, which feature is impacting it? Are those the right ones? But now you're looking at the decision for a particular record. So for example, I think the thing in the notebook will talk about record number 400. I don't know if you can kind of find that.
Yeah, record 400 has not worked on this model for some reason.
Okay, well, we can pick another one and see if it makes sense. Oh, yeah. So for example, what you're seeing over here, if you looked at the individual tab, you will find that the records at a high level are grouped into the things that are successes and the things that fail out of the 696, 112 versus the non-112. So you know that in the 112 records, you know that the decision was wrong. And you want to understand, like, why was this decision wrong for this particular person? So if you click on that person, it now gives you a sense of, for that person, why was the decision made? We already know the decision was wrong. So if you click on that, can you see the visual thing? Otherwise, we can look at it in the notebook.
Yeah, it's not worked on this model, but it's this visual.
Okay. Yeah, so it's this visual. If you pick 400 in here, this is really interesting, right? Because what we're seeing is we're looking at all the different features that we were using in our training model. And it's telling us that for this person, we made the wrong decision. We said that they shouldn't be readmitted, but they should have, I think that's what it was. Yeah. And when you look at it, you can see the things that were wrong. Like, so on top, right, what were the things that impacted the decision most were the number of diagnosis, the race, and the, can't even read the last one, but it was, what's the last one?
That was a discharge destination and numerical medications. So were they on medication?
Whereas the things that impacted them the least were the ones in the middle, right? Like, did they come? So here, this is immediately a warning flag for us. It's like saying, why was race one of the top features that was used to impact this decision? This can't be right. So this is when we go back and say, wait, was it a data set problem? Was there something else that the model was underrepresented perhaps? Or maybe the people that came from there had a certain kind of context that we're missing. Should we have had more features? I don't know. But this is the kind of thing that is important for us to drill down. Now, this is important for two reasons. One, it lets you see for an individual, hey, I can explain to you why you got the decision you got, because I can see this now. But I can also do, and we're not going to cover that here, but you can use this now to do things like causal analysis and counterfactual thinking, right? You can say, now if I think about this, they should have been admitted. So what should I have done that would make them? If I look at this, it says, it turns out that what are the two? They've had a prior emergency. Not that I'm recommending that people should get a prior emergency to be admitted. But what we're saying is we're also understanding what are the things that actually move them towards that right decision. And we can kind of say, hey, I can explain to you why this happened. Either it's a problem in the model that I need to correct, or there isn't a problem in the model, but it requires you to have had X, Y, Z. So there are other tools that will help you do that kind of thinking as well. So I think I wanted to make sure we covered this because we're kind of almost at, I think we have about 10 minutes left, if I'm not mistaken.
And again, just to stress to people, if you do not see error 400, so in my case, when I ran the model, number 400 wasn't created. It does state in the instructions occasionally 400 does not load. It's normal behavior for this lab. It's an issue with the lab, I think, but at least you're aware that, you're not going mad if you don't see 400 in the list. It is an issue with the lab.
Yeah, and so, you can. So go ahead.
Sorry, go on. No, go on. Sorry.
I was just going to say they should pick, feel free to go pick another record and try to analyze.
Yeah, there you go.
Insight to analyze stuff. Yeah.
Yeah. So if you pick the record, it does populate the detail below. So if you just scroll down, it shows you the detail below. Excellent. If we go back to the slides then.
So I think we can skip this one because we actually did this already.
We talked through that, yeah. So let's just cover, quickly what we've done. So we've done the introduction. We've done what is responsible AI dashboard. As you can see, putting it all together on the same view is really key. The inherent analysis and model, being able to dive into that model, prove what the data is within that model, then look at where the performance is. So I think the race one was really great in terms of an example of just being able to see that scatter plot. You can immediately take that to your leadership and say, look, our data's wrong. Why is it wrong? Look, this is clearly evidential why it's wrong. It exposes the data bias. You can explain, interpret the model, which you couldn't do just looking at the raw data. We've talked about how we can launch those as exercises and labs and use the sandbox environment without an Azure subscription. What we're now going to do is do a quick knowledge check. So we've got 3 questions, and then we'll go into a summary. So the first question, so I don't know if the poll's available. If the poll's not available, please add your answer to the chat. But the question is, after successfully running a training job, What's the final step in the workflow to make the trained model available for future predictions? Is it register the model, A? B, create a new job, C, transform the model, or delete the compute cluster? So which one do you think it will be?
Well, I don't think it's D. Let's just do that.
I don't think it's D. What do people think?
Yeah, I'm waiting to see if anyone is. Oh, A. Okay, we've
So
got one
Jason's
A.
saying A. Anybody else saying A? Again, if you've got your outline view open, it should be very clear to which one it is.
We got 2. We got 3.
So yes, it is A. Well done to everybody who said A. It is register the model. The next question, what does the feature importance component in the responsible AI dashboard creation process do? Does it A, it configures the overall feature error rates, B, it calculates error distribution, C, it initializes the global data of the component, or is it D, it provides a better understanding of what features influence the model predictions?
Yeah, and I'm going to say that anything coming from now, because I'm seeing a lot of A's, I'm guessing those are for the previous question.
Yeah.
Okay, so now I'm seeing
type D.
Yeah, D.
People are thinking D for this one. Yes, D is the correct answer.
Woohoo.
So the last question, why is the data imbalance in the test data a concern when using machine model learning? A, it increases the model accuracy. B, it makes the model evaluation easier. C, it might lead to fairness and inclusive issues. D, it has no impact on the model performance. So a few people are saying C. Any others? Oh, Salmon's here. Hi, Salmon.
Yep.
C, everybody's. I think they've all been listening to us, which is great. It's a C. Yes, it is C. So what we've done today, Nitya, we've looked at the different notebooks. So these are part of the module, which the exercise is notebook 1, notebook 2. We've looked at the UCI hospital data set, which is that 10 years of data set, looking at all those 696 records across all the different hospitals in the US, looking at patients with diabetes. And we've analysed if a person has diabetes, should they be readmitted to a hospital within the next 4 days? We've built a responsible AI dashboard. We've looked at the data within the dashboard. We've also looked at the sandbox environment and the instructions and then how to utilize the sandbox and the explanation of more detail around what does that data and how is the data interpreted. And then we've used the actual dashboard to debug our model and highlight where there is bias or inaccuracies of data within that model.
And someone had actually asked about the notebooks. We'll make sure that we put links in there. There are 2 different sources. This particular notebook used in here, you're more than welcome when you're on that to just copy it into a notebook in your own space. But there is, if you go to the responsibly AI the toolbox AI URL that was in the chat previously, you will find that there's actually a whole bunch of notebooks that can use to just play around with different ideas. And then you'd have to obviously use the Azure component of it from this one.
And we'll also put into the chat as well the responsible AI training resources that Nitya has built as well. So we'll add a link to those.
Yes,
so
there's a great collection to track. Yeah.
Nitya, I'm going to pass this over to you and I'll grab that link as well.
Awesome. So I hope we did our job right. And if we did, you probably will take away 4 messages from this. First of all, we were talking about model debugging. And your whole model debugging journey starts with error analysis. The error analysis tool is really focused on asking you, on the left side, you can see, it says, hey, my model's 89% accurate, but when I dive in, I can see that the cohorts, the different subsets of it don't have an even distribution of error. There are some which are red, which are really, really not as accurate. And there are some which are green, which are totally accurate for that demographic. So with the error analysis dashboard, you find a tool that lets you dive in, buy code, save it, and then analyze it. Next slide. Once you've got your error cohorts, the next thing you're looking at is performance evaluation. You really want to understand how is your model performing for those cohorts. You want to look at it and say, hey, let me look by those cohorts and compare them for everyone. Then for this cohort, I'm looking at metrics like false positives, false negatives, total accuracy. I can look at the probability distribution. I can visualize the metrics. I can then kind of say, hey, within this, can we go dive into features? So the performance evaluation dashboard is now allowing you to go by cohort and analyze your model for anything that might be kind of like away from your normal or average behavior. Next. Once you've done the model debugging, once you've kind of got your error analysis and you've looked at the data, you're really looking at fairness assessments as one of the critical things for responsible AI. Not only is, kind of what are the features impacting this distribution of error rates, but do you have blind spots in your data? Is your data over or underrepresenting demographics that are being impacted by the decisions based on that model's prediction? So you saw that through kind of like the example at the end, where we're able to look at it by race and say, hey, are we seeing decisions being done differently for an individual or for a collective based on that particular cohort and so on? So this gives you a starting point to say, well, maybe I need to do a little bit more analysis on where I get my data, whether I need to be adding more features, is it representative? Next. And last but not least, the fourth thing that we looked at is we really want to explain the model behavior. So this actually, believe it or not, has two implications. One is we want to be able to explain to a user, hey, your decision is because of this, right? And that allows us as data scientists and developers to also think about what would that user have to do to get a different decision? But the other side of it is this is actually very, very critical for governance and accountability as well. The transparency part of this is to say that when I want to, like, say, audit my models, I want to be able to tell you why they took the decisions they took. So assessing the model is not just about knowing did it make the prediction accurately, but really being able to explain why. And so over here, we can not only explain why the decision was made, but we can also use it to say why the decision was perhaps wrong and how we could be correcting it, right? So you move away from this black box where you don't know what's happening. You just get this, here's what the decision is on your loan, to saying, oh, okay, we understand that you got this decision because you fit into this kind of like cohort where these were the features that were important. And if we perturb a feature, you might move into another cohort where your outcome might be different.
And again, Nikki, that feeds back into the 6 pillars of trustworthy, transparency, accountability, security, etc. So this is what we've done today. So as a quick summary, then, we've understood responsible AI principles. So the 6 pillars of responsible AI. We've created the responsible AI dashboard by building a dashboard from a data set, using Visual Studio Code, using the Azure ML SDK. We've then identified the model that has errors and been able to identify that within the dashboard and look at the actual status of the model, the different aspects of the model, and again, identify where there is bias or where there is uncertainty in the quality of the data that is there, which we've identified as underrepresentation within the ethnic minorities and also within ageism. So there was some ageism within there as well. We've understood what the drivers of the models and the outcomes can lead to. And then hopefully, this gives us some ideas to how to mitigate issues and meet compliance needs of those models. So it's not answered all the questions. It's giving you a set of resources that you can then go now and start to build upon to answer those resources. So again, you can actually do this in your own time. So this is all available. It's completely free to do. Please have a dive into it. You can do it again further, so you can do it, keep on doing it if you want, and get really good at doing this. It is a time-bound sandbox, so it does last only a certain period of time. Again, this is part of a future series, so please do, join the Cloud Skills Challenges and the AI Challenge. The QR codes and the URLs on the screen link to this current series and the next episode. So the next episode is going to be on April the 11th, which is tomorrow at the same time. And that's going to be on how to interact with models using OpenAI. So this is actually getting more into the model development and deployment and interaction with the Azure OpenAI services. Again, if you're interested in answering more questions and getting more involved, we have a dedicated AI community Discord channel. We've got over 6,000 people in this channel already. You're there to ask questions, share your experiences. We have roundtables with the product groups. We have Microsoft Value professionals in there. We ask you to what you're interested in. So we have spaces and roundtables where we will discuss topics that you bring to us. So please do join and take part in these activities. And it's been a great episode, and we're dead on time, Nitya.
Yeah, huge shout out to Cynthia and Carlotta for all the moderation, and to all of you for all the questions, and Daniel for keeping us on time.
And thank you for all the audience for being here. So this will be made available on demand and available in the future. There was some questions around security and privacy. You know, the data set we've used is completely anonymized. Again, you do need to look at the data integrity when you're building these models with your own data. So, you know, data security is key, and there's lots of guidance around data security. Thank you, everyone. Have a great day.